Hello friends, welcome to TechnoBazaar. This is Rohit Sharma and this is a video number 5. Okay, and this is going to be published on 19th of November, and this is the last video for our subject, for our first subject, that is network theory, and the topic for this video will be resonance. Okay, so resonance are a very short topic. In this I am going to explain some formulas based on resonance. What is resonance, series resonance, parallel resonance, and 2 or 3 numericals based upon resonance. Okay, so this is a 45-day strategy that was started on 11th of November, and 4 days off is taken for Diwali in between. And those who have not subscribed the channel, please subscribe the channel. And for quiz tournament, you can download our TechnoBazaar app. Link is available in the YouTube description. Okay. Before starting the video, there is a announcement. Crash course is available on Mechanical Atta app. You can purchase it, and good number of questions were taken in that course, and around 180 plus videos are there. Okay, so ISRO TA test series is also available at Mechanical Atta, in which total 2000 questions are based on ISRO TA pattern. 15 basic tests are there, 7 mixed tests, 2 numerical tests, 16 full syllabus tests. Subject wise courses are available at TechnoBazaar app. Those who have difficulty in one or more subject can purchase from there. And quiz tournament is available free of cost at TechnoBazaar app. You can daily attempt it at 7 PM, or you can purchase the whole quiz tournament test from the store at a cost of ₹1 only. Okay, now I'm going to start the video. Now, what is resonance? So resonance, for the occurrence of resonance in any system, 2 energies are required, and in any electrical circuit, these 2 energies are provided by inductor and capacitor in the form of magnetic field and electric field. Now, all of you know that inductor stores energy in the form of magnetic field, but the capacitor stores energy in the form of electric field. Okay, so capacitor stores energy in the form of electric field. Now, if I say what is the formula for inductor store energy due to inductor, then energy due to inductor is 1/2 Li square, but energy due to capacitor is 1/2 CV square. Okay, so please remember these formula. So at resonance, the voltage across inductor and the voltage across capacitor will always be equal. The magnitude will be equal, and we know that VL is equal to IXL, current into inductive reactance, which is equal to VC. VC is equal to current into capacitive reactance. So I can say at resonance, XL is equal to XC, that is inductive reactance is equal to inductive capacitance. Okay, so from here, XL, we know that XL is equal to omega naught L, and XC is equal to 1 upon omega naught C. From here you will get omega naught, that is the resonant frequency, which is equal to 1 upon root LC. This will be in radian per second. Okay, from here you can also find F naught, because we know that omega is equal to 2 pi F. From here you can find F naught. So F naught is equal to 1 upon 2 pi root LC, and this value will be in hertz. Okay, because the SI unit of frequency is hertz. Okay, so the circuit is said to be in resonance when the source voltage and source current are in phase. That means the source voltage Vs and Is are in same phase. Okay, so only resistor will act here. Okay, the resonant frequency indicates the rate at which energy transformation takes place between the inductor and capacitance. So this is all about resonance. What is resonant? What is resonant frequency? What is the condition for resonant? That is XL equal to XC or VL equal to VC. This is all about resonance. What is resonance? Now let's see some. This is a graph between impedance versus omega, that is the resonant frequency. So for an RC circuit, this will be leading here. Okay, this is at resonance, or you can say the unity power factor. Okay, here this will be lagging in nature. Okay, for X versus omega, X is equal to XL minus XC, which is equal to omega L minus omega C. Here for a series resonance circuit, here this will be series, here this will be leading in nature, RC circuit, and here this will be lagging in nature. Okay, these graphs are not very important, just you have to remember the formula for your exams only. Okay, so this is some BTech point of view. Okay, so here this is the graph between current versus resonant frequency. Here at this point where you are getting the maximum current, this is at resonant frequency, or you can say at unity power factor. Okay, because here resistance is only acting, and here the Vs is the source voltage is in same phase with the source current. Okay, so these are the 3 graphs. Okay, and please remember this, for omega less than omega naught, when omega is less than the resonant frequency, then impedance is equal to R minus Jx, or you can say it is in RC nature, or you can say it is in leading in nature. For omega equal to omega naught, then it is a unity power factor, and impedance is equal to the pure resistance. For omega greater than omega naught, Z is equal to R plus Jx, that is RL circuit. The power factor is equal to lagging in nature here. Okay, so variation of voltage across the inductor and capacitor with respect to frequency. So if you are seeing for an RLC circuit, RLC circuit, always the inductive voltage VL is equal to the capacitive voltage, but it is always more than the source voltage. This is known as the voltage frequency. At the resonant frequency, the voltage across the inductor and capacitor is equal, and it is more than the source voltage, and this process is known as voltage magnification. Okay, so I can say VC is equal to I dot XC. So I is equal to V by Z, and Z is equal to, here is R plus JXL minus XC. If you are finding the magnitude of current, the current magnitude is equal to Vs upon root of R square plus XL minus XC ka whole square. From here you can get FL, that is the FC. This is equal to 1 upon 2 pi root LC bracket 1 minus R square C upon 2L. Okay, that is the capacitive frequency, and here this is FL is equal to 1 upon 2 pi root LC root of 1 upon 1 minus R square C upon 2L. Okay, so you can remember these formula, can be asked in your exam, and this I have already explained to you. For omega equal to omega naught, for omega greater than omega naught, for omega less than omega naught. For omega less than omega naught, it was working as RC circuit. For omega greater than omega naught, it was working as RL circuit, that is lagging in nature, and for omega equal to omega naught, it was a unity power factor, that is a pure resistive circuit. Okay, this you can read it by your own. Now what do you mean by quality factor? Now quality factor is defined as the maximum energy stored in the circuit to the energy dissipated per cycle of oscillation, or you can say by formula Q is equal to 2 pi into maximum energy stored in the circuit divided by the energy dissipated per cycle oscillation. So if I am adding both the energies, energy due to magnetic field and the energy due to capacitor, or energy due to electric field, so 1 by 2 Li square plus 1 by 2 CVC square, I can write this. Okay. On deriving the relation, you are getting quality factor as Q is equal to omega L upon omega L upon R. Okay, you don't have to remember these equations, these derivation, just you have to remember Q is equal to omega L upon R. Okay, so another formula by derivating is, another formula for series resonance circuit is 1 upon R root L by C. Okay, Q is equal to omega L by R. This formula is valid for both series resonance as well as for parallel resonance. It is valid only for series resonance, and Q is equal to 1 upon omega RC. Q is equal to 1 upon omega RC here. Okay, these all formula are valid for series resonance circuit. Okay, so here at omega equal to omega naught, VR is equal to, that resistive voltage is always equal to the source voltage. At omega equal to omega naught, that is at unity power factor, and here source voltage is in same phase with the source current. Okay, for VL and VC, this will be equal to JQV, and VC is minus JQ. This is the voltage amplification factor at resonance. Okay, so now what is bandwidth? It is the range of frequency for which the power level in the signal is at least half of the maximum power, or you can say omega 2 minus omega 1 is the bandwidth. Okay, it is the range of frequency. Okay, so here at omega equal to omega 1, and directly writing the formula, you don't need to remember these derivations. For this, bandwidth is equal to R upon L radian per second, which is equal to R upon 2 pi L in hertz. Okay, so please remember these formula. Omega 1 omega 2 is equal to omega naught square. Omega 2 minus omega 1, that is the bandwidth. Okay, it is the range of frequency. Upper cutoff frequency minus lower cutoff frequency is the bandwidth, which is equal to R upon L, or you can say omega 2 plus omega 1 ka whole square minus omega 2 minus omega 1 ka whole square is equal to 4 omega 1 omega 2. These are some formulas based upon this. You can see this, and you can say quality factor is also known as resonant frequency upon bandwidth. This formula is also valid, and the damping factor is equal to 1 upon twice of quality factor. Okay. So these are some formulas based upon the series resonance. Now for a parallel resonance, in this R, L and C all are connected in parallel, and here bandwidth is equal to 1 upon RC radian per second. But for series resonance it was R upon L radian per second. Here zeta is 1 upon 2q, quality factor is omega naught upon bandwidth. Okay. Same resonant frequencies will be same here. Omega naught is equal to 1 upon root LC, or F naught is equal to 1 upon 2 pi root LC. Okay. These are some graph, you can check this. Here this will be lagging, this will be leading for admittance versus resonant frequency, for bandwidth versus resonant frequency. This here, this will be RL, this is RC. Same for omega less than omega naught, it will be lagging in nature. For omega equal to omega naught, unity. For omega greater than omega naught, this will be leading in nature. Okay. Here, what will be the formula for quality factor in the case of parallel resonance? Here, this will be R root C by L, but in the series resonance case, that was equal to 1 upon R root L by C. Okay, and here the quality factor is equal to R upon omega L, or second one is okay, these are some formula, or one second, and also one formula is there. There in the series resonance circuit, the quality factor was 1 upon omega RC, but here for a RC circuit, quality factor is equal to omega RC here. Okay, so please remember these formulas based upon the parallel resonance for quality factor. Okay, at omega equal to omega naught, now we will see here the resistive current will be equal to the source current, and IL and IC. For this, IL equal to minus JQI is the current amplification factor, and IC is equal to plus JQI is the current amplification factor. Okay, so next is, let's take one question based upon the resonance. In the below given circuit, find the resonant frequency, that is omega naught, which is equal to 1 upon root LC. Okay, root LC. Half power frequencies we have to find, quality factor and the bandwidth. R is given, L is given, C is given. So I am omega naught is equal to 1 upon root LC, L is equal to 1 millihenry, C is equal to 0.4 microfarad. On substituting the values, you will get 50k radian per second as a resonant frequency. Now this is a series RLC circuit. Now series RLC circuit, quality factor is equal to 1 upon R root L by C. From here you will get Q is equal to 25. Now you have to find bandwidth. Bandwidth is equal to omega naught upon Q. From here you can get 2k radian per second. And similarly you can find omega 1 and omega naught, that are the half power frequency. Okay. So this is how you can find this. Omega 1 is equal to omega naught minus bandwidth divided by 2, and omega 2 is equal to omega naught plus bandwidth divided by 2. This is how you can find the half power frequency. Last question based upon this is, find the resonant frequency for the below given electrical network. So this is the electrical network. I am taking this as impedance 1 and this as impedance 2. Okay, so let's see how we will do this question. Now procedure for finding the omega naught here is, find the equivalent impedance. So Z1 is equal to XL minus XC. XL minus XC. Okay, so one second. So this will be equal to J bracket 4 omega minus 1 by omega. Z2 is equal to minus J upon 1 by omega. Now both were connected in parallel, so total impedance will be equal to Z1 parallel Z2. From here you will get Z is equal to 4 omega minus 1 by omega into minus J upon omega upon 4 omega minus 2 upon omega. Okay, so Z equivalent is equal to 5 plus Z. Okay, because 5 was connected in series here. Okay, so 5 plus Z. So total equivalent impedance will be equal to 5 minus J, that is the imaginary term, is 4 omega minus 1 upon omega into 1 upon omega bracket 4 omega minus 2 upon omega. Okay, so at resonant this will be 0. I am taking the imaginary time as 0. So on taking imaginary time as 0, so you will get 4 omega naught minus 1 upon omega naught is equal to 0. 4 omega naught square minus 1 is equal to 0. 4 omega naught square is equal to 1. Omega naught square is equal to 1 by 4. And you, on taking root, you will get omega naught is equal to 1 upon 2 radian per second is the resonant frequency for this question. And these are the questions based upon the resonant frequency. If you have any doubt related to this resonance, and this is the last video for this subject, network theory, or I have completed network theory in these 5 videos, and total all the chapters revision is taken in these videos. If you have any doubt related to network theory, you can ask me in the YouTube description, or Telegram group or Technivizard, Mechanical Adda, anywhere you can ask me. Okay, and I am here to help you. Till then, take care of your health, all the very best, and we will meet in our next video, that is tomorrow, 20th of November.